Hello, let's look at using shared mutable state with Actix-web and Postgres. So Actix-web is the framework for writing an API in Rust. And I've got a Postgres database with some fake example data in it. And I'll just demo what this does. So I'm just going to make a curl get request, which will go to the database and it should retrieve the username and the email. So as you can see down here, I'm using Rust log info level, and it says cache hit for user ID 91. So it's using cache, and that is part of what I was trying to teach myself with shared mutable state, and why you might want to might want to capture the state. And it's good practice for using Arc and Mutex, because obviously up until now, or not obviously, but up until now, I've only been doing examples from tutorials and so on, and nearly every Arc Mutex example has just got a counter. And you think, well, that's all very well, but what's the actual practical application of that? So we'll look at the code in a second. So if I just go to a different one, let's go to user 99, you can see it says stored user 99 in the cache, because the cache was a miss. So user 99 wasn't already in the cache, but if we run it again, it will be in the cache and it should say cache hit. Yeah. So that's the demo. Let's actually look at the code. So as I said, I ran it using rust log equals info because I've set up logging because I wanted to see what was going on. Okay, so, and I'm just getting it to print my environment variables there. I've stored that in my ZSHRC file. I've exported that. Okay, so let's actually look at the code. Let's actually look at cargo first. I'll just show you what's involved. So Actix-web, just zoom in a bit. Maybe that's too much. There we go. So we've got Actix-web 4.9. This is being recorded in August 2024. So if you're watching it in the future, then you might want to upgrade that. .env logger. So .env reads the database connection details from either a .env file, or you can load it from your ZSHRC when you start that. env logger, log. So these are I don't know if I used both of those. I definitely used one of them. I had a trait. I had a future deprecation warning with one of them. I'll tidy this up in due course. Postgres, Surday with derive, because I need to use serialize and deserialize as always. It would be amazing if that was just included as part of the standard library. But Surday JSON and SQLX with the runtime Tokyo Rust TLS, Rust LS. So let's look at the code. And Actix.env, so SQLX PG pool. So you'll have a pool of database connections available. I can't remember how many that is by default, but it might be 8 or something. Is it this? I think it might be the same number as the number of cores on your machine. Don't quote me on that. Use standard sync arc mutex. I've done this so many times with tutorials, but it's always just been with a counter, as I said. So we create a struct to capture the app state, which will store the number or store the DB pool of connections, and that's not actually using an arc or mutex. That just gets cloned later on. This one, however, does. So you've got multiple threads accessing the cache. So obviously you could have many people accessing this API, and it's currently in the cache, and 2 people were trying to access the same record. Then it would make sense to share the same cache, so that if user ID 91 is cached, then you've got two remote connections trying to access that, then it would make sense that they can both share it. The user, these three fields here, ID, name, and email, need to match what you've got in your database. I was asking ChatGPT for help, and it gave me like ID and name as kind of an example, and I ran my code, and then the Rust compiler actually said you need to add email as well, and then I thought, oh well, yeah, that's right. That I knew that I had email in my Postgres table, so by adding that line, it then compiled. So we've got a function here called getUser, which is quite long, and it's using match, so that's why it's looking for a couple of errors as well, like user not found or internal error. I'll come back to that in a second. So here, this is the main. So Actix uses in Python, I'd call it a decorator. I forget what it is. It's an attribute, isn't it? It's a message for the compiler, basically. Async function main. So we have to return a standard IO result, and I'm initializing logging here. I'm reading the database username, login, password, etc. from the .env. Well, it's not the .env, but it could be. Database URL must be set, so you get an error if that isn't set. So that's just the connection details and turning logging on. This is where we say the pool. So the pool is basically the database URL, and it's creating a pool of connections available. This is where we're using the arc new, mutex new, hashmap new, and that's the cache. And that gets added to when we do the get user function, which we'll go back up and look at in a second. So we've got the HTTP server instance, and then we've got the app instance, and you have many of these inside your HTTP server. You have one per connection request, I believe. And then we're just going to bind it on port 8080. You can choose whatever port you want, and then you do run, and then you do await, and it's await because it's asynchronous. Yeah, so let's go back. We're using the clone of the cache. So that's not actually cloning the cache, it's cloning the reference to the cache, as I understand it. And here we go. This is the good bit. So async function get user. We'll pass in it in, the app state, which is of type web data. So up here, we use web there. That's what's happening there. The app state is this. So that needs to contain the pool and the cache. And then once you get inside the function, then you're using user ID to inner. Into inner is an Actix-web function, which basically takes the inner value out from the data, the web data, which is the app state, which is that struct there. Let me turn off the. Yeah, I have. Yeah. I did need quite a bit of help from ChatGPT with this. I understand the Mutex, but using the Mutex in a real world application, and that's all I really wanted to do was to use Actix-web with Postgres. So that's two fairly common things. But I wanted to use app state, and I wanted just to use it really with one Mutex example. So the cache, come down here. We take the cache, we take sole ownership of it here, and then we get cache hit for user, and then we get the user ID. If it's not already in the database, we just log that. We say the cache miss, so it's not already in it. If it's not already in the cache, then we go ahead and fetch it from the database. And then this is what gets returned if the query from the database goes ahead. And the two values in the cache are the cache key and then the user data. And if you remember, the user data came from user data, which is user data equals cache get cache key. The cache key, came from here, which came from the user ID, which came from there. So you got user ID, which goes to there. Then that goes into, you get the string of it. And then from that string, you then extract cache key. With the cache key later on, cache key is the key, which you're inserting. Then you've got the user data. So I probably wouldn't be able to write this from scratch, but if someone gave me this code, I would probably now know what would, if I saw it and there were bits missing, I would probably know what to go off and find and edit and fix. So we run it again. So it's rust _log equals info. Let's try debug. See what difference it makes. So the kill command is basically just go into localhost 8080 and then /user and then /ID. In debug mode, we get SQX query summary. That's nice. That's given us a nice lot of information there. And you can see how quickly it did it, 3 milliseconds. And you can see it's now stored the user ID in the cache. So that's done the insert into the hash map. So this will store it in memory. When you obviously when you run it next time, it won't be there. So every query you run, first time it will be missing, then it's hit. So you see cache hit versus cache miss. So the main reason I wanted to do this was just to start getting some real world experience or practice with using Arc and Mutex, and I understand the overall concept. I do need more practice on actually being able to kind of write this from scratch, so to speak. I understand the SQL query. I understand here that you're cloning the reference, you're not cloning the actual data itself. Yeah, and that's the user and the user ID, and that's what we're passing in. See the user ID, and that matches that there, look. So I'll put this on GitHub. If anybody wants to copy it, then you're welcome. And really, this is practice at using Actix-web with Postgres and using Arc and Mutex, compared to a lot of the tutorials where you will just be using a counter and you'll be just having multiple threads update the same counter. So shared mutable state. The state is the app state, which you create as a struct. You need to add derive clone because you want to be cloning it later on because you're cloning the reference. And then the atomic reference count keeps a count of how many references there are. The mutex means that there's only one thread allowed to mutate the data at any one time. And then the hash map is the actual data that you're working on, where that is the cache and that is the actual user data. So for me trying to explain this has been quite challenging, but the code works, and it's probably something that you can look at, experiment with, take apart, break, modify, so on. So obviously the Actix side of things, if you don't use Actix or you don't want to use Actix or you'd rather use Axum or Warp or whatever, then that's fine. But at least you can still grasp the overall concept where you are using shared mutable state. And shared mutable state it's applicable to logging, caching, potentially a database pool. So here, this isn't behind an arc in the mutex. I just wanted to do it on one variable here, so that's what I've done. And the user, so that's just that's just what you have in your database. So if you've got these 3 columns in your database, then it will work. You can just create a Postgres table. Do you have to use Postgres? Yes, because it's using Postgres there. Like, you could modify it. So rather than using Postgres there, you could use whatever other flavor of database and then adjust it accordingly. Remember to use derive. I always forget, or not always, but quite often forget to do that when I just do cargo add survey. Then you'll get compile errors. So thanks for watching. Hopefully this is shown a bit more about a real world application of using Arc in Mutex. And we've also looked at using Rust log, which is quite good. And I think something I really need to just get in habit of always using on anything other than just a little toy project. Yeah, so there we go. And cache, that's obviously something that is really useful and beneficial, and it'll speed up your application. And there we go, we've got 8 workers. So I think it's because I've got 8 cores. Don't quote me on that, but yeah. Postgres, Rust, Actix-web, and using Arc and Mutex for a real world use case. Thanks for watching. I'll be back soon. Thumbs up, like, and all that, yeah. Thanks.